If the MX6 is going to be used for confined space entry, it is always recommended, of course, that the sampling pump be in place over the instrument. The sampling pump allows me to draw a sample up to 100 feet, and the instrument should not be used for confined space evaluation unless this sampling pump is in place. Now before we use this instrument with the sampling pump, we always want to check the functionality of the pump by blocking the inlet port. By blocking the inlet port, we want to make sure we do get a pump fault indication on display of the instrument. This checks two things. One, it verifies that there is blockage in the tubing. I will be notified on the instrument display. And two, it also checks to ensure there's no splits or holes in the tubing, ensuring that the gas is only being drawn from one place, and that is at the end of the tubing. But there are certain sampling criteria that we ask the user to follow to ensure that a proper gas test of the confined space is being obtained. This is what we call the when, where, why of atmospheric testing. When we're going to sample from a confined space will always be prior to entry. We always want to sample prior to entry to see what we're getting ourselves into. But if I get out for a small smoke break or for lunch, I'm also going to want to sample prior to re-entry. Even though I've been out for a short period of time, I always want to sample prior to re-entry in case conditions in that confined space has changed from the short time I've been out. But not only do I want to sample prior to re-entry, but if I'm going into that confined space continuously, I'm also going to sample. Even though it was safe prior to entry, even though my readings were safe, I still want to continuously monitor while I'm in that confined space because I want to ensure that if the conditions inside the confined space change, that my instrument will then provide me notification of that change, because the work being provided in that confined space may be turning what we believe to be a safe atmosphere into a very dangerous one. Okay, but also where? Where are we going to sample from within the confined space? We always want to sample at the top of the confined space, the middle of the confined space, and at the bottom of the confined space. So we're going to sample the top, middle, and bottom. In the US, OSHA recommends that you do this in 4-foot increments. So you go top, 4 feet down, 4 feet down, 4 feet down till you get to the bottom of the confined space. And why? Why do we want to sample top, middle, and bottom not to exceed 4 feet? Because of stratification of gases. Some gases are heavier than air, some gases are lighter than air. Some gases may settle at the top of the confined space while others may actually drift or sink to the bottom of the confined space. Look at a gas like methane, for example, which is a lighter than air gas. It may actually stratify at the top of my confined space. Carbon monoxide, which is slightly lighter than air, will mix pretty well throughout the confined space but may stratify somewhere in the center. Whereas hydrogen sulfide, which is a heavier than air gas, may actually sink to the bottom. Now these gases may find their area of stratification if the gas concentrations are high enough. If the confined space has been buttoned up for a long enough period of time, these gases may actually start to find their areas of stratification. Now does that mean I can only find hydrogen sulfide at the bottom of the confined space? No. Get a little bit of ventilation in there, these gases can be found just about anywhere within the confined space. But by sampling at the top, middle, and bottom, I'm ensuring that if these gases have stratified, I will find their area of concentration. The last thing we want to keep in mind when drawing our sample from within the confined space is what? What are we going to sample for within that confined space? Well, according to 29 CFR 1910.146, subsection B, before an employee enters the space, the internal atmosphere shall be tested for the following conditions in the order given. And it's important that we do this in this order. We want to ensure that our oxygen content is between 19.5 and 23.5, and that our combustible gases are less than 10% LEL, and that our toxic gases are beneath the permissible exposure limit. Once again, though, you want to ensure that you are following company policies or local regulations when looking at these actual concentrations. The reason we want to always take note of our oxygen reading before we take note of any other readings is because oxygen is our #1 killer. More people die from an oxygen deficient environment than any other hazard in a confined space. But most importantly, it's going to also reflect directly on how our combustible gas readings will read. I need at least 10% oxygen for the combustible sensor to work properly. If I don't have at least 10% oxygen, my combustible gas readings will be erroneously low. Therefore, when I'm drawing a sample from within a confined space, if the O2 levels in that confined space are less than 10%, don't even look at the combustible gas readings because they'll be reading erroneously low. Provided I have at least 10% oxygen, I can look at my combustible gas readings with good faith knowing that the concentrations they'll be reading should be accurate. One aspect you always need to keep in mind when drawing a sample from the confined space is ensuring enough time for the sample to get up through the tubing and delivered to the sampling pump. This is something we call the 2 and 2 sampling rule. What the 2 and 2 sampling rules shows is that you want to allocate 2 seconds per foot of tubing, and then you want to add 2 minutes of sample time on top of that. The 2 seconds per foot is just to purge out whatever's in the tubing. The 2 minutes on top of that is to obtain the most accurate reading that you possibly can. So in an example of 20 feet of tubing, sample draw time would be 2 minutes and 40 seconds. 40 seconds will just purge out the 20 feet of tubing. The 2 minutes would then be used to obtain the most accurate reading that I possibly can.